and do it. If you missed it, then you missed it. All right. I am teaching this course in the spring. If it doesn't work out for you, I'm here for you. You can take me again. I'll give you the red carpet treatment. If you don't take me again, that's fine as well. You usually don't supposed to take the professor who you had in the past and it didn't work out. You're usually supposed to take somebody else. But I will say this, that the great majority of the class is doing really, really well. They've seized the moment, they've seized the opportunity, and we have some high, high grades. Um, I, I, I mean, it's to the likes to where I've almost never seen. So it's that high. So I'm really happy with how people are thriving in the class. That motivates me, and I think that it's a testament that if you want it and you want to go after the high grade, it's attainable, and just nothing can stop you. You know, you get that stats down, you are going to be better for it. So we are here. Yeah, then you guys should be able to see the light at the end of the tunnel at this particular moment. All right, so let's talk about that final exam a little bit, or maybe we can jump into that quiz 4 a little bit too. Yeah, chapter 10 will be on there, and I'll talk about the breakdown of that as well. We should touch a little bit on chapter 10. I think there's some chapter 10 problems on that practice final that we can take a look at, but I actually haven't uh, I really haven't looked at the quiz 4. Okay, I just got locked out of it. Um, yeah, I actually haven't took a look at that quiz 4. I may have. I should be able to. Well, I should have access to it. Let's see. Okay. So even I got locked out of it. The quiz 4. I could probably let's see if I have it somewhere else. Let's see here. Okay, so what the problem is that you should have this setting to where once the test is done, you should be able to go back in and review it once the due date has passed. You can't do it right after the test, but once the due date has passed, which it has now passed, we should have that ability to go back in, and then we could preview those problems. So that's what I'm going to do right now. I'm just going to make sure that for quiz 4, you have the ability to go in and see the questions there. Alright, so we're just taking care of some little technical glitches and getting ready to dive into the statistics. Just kind of crossing our T's and dotting our I's right now. All right. Yeah, it seems like, am I in student view? It kind of seemed like I was in some kind of student view for that. No, oh yeah, that was the button to go into student view. But I think right now we should be fine now. We should be able to access the quiz, and I can pull it up in other ways as well. So I actually never took the test, so I can't review it since I never took it. Um, checking this one. All right. Okay, guys. It looks like we've made some progress in actually accessing quiz number 4. Um, hmm. All right. And I think we have the ability to go forward and back, or I don't know how they'll do it, but this is the kind of question that was on quiz 4. This looks like a chapter 8 question, and so let's kind of dive into it and see how we actually solve something like this. Now, the thing is about a hypothesis test, again, it is the most powerful statistical test. It holds up in the court of law. The results are conclusive. If you get conclusive results, they're undisputable because you are essentially have collected enough evidence to say something is true or false with a high degree of probability. Um, let's take a look at this. It says a certain drug is used to treat asthma. In a clinical trial of the drug, 24 of 279 treated subjects experienced headaches. The accompanying calculator displays shows results from a test of the claim that less than 10% of treated subjects experienced headaches. Use the normal distribution as an approximation to the binomial distribution and assume a 5% significance level to complete parts A through E. Now, because they said that the claim being tested is less than 10%, that lets us know that our alternative should be written less than 10%, or H null, H1 rather, should be strictly less than 0.1. And that lets us know that we are dealing with a left tail test. Let's see if we can. It's kind of a good problem to study. I wonder if I can. Okay, they don't even let you print it to anywhere else. Just kind of frustrating. All right. What I can do is let's make it a little snip there, so now I can write on the screen easier. So here's the thing. H null, and we're dealing with a proportion because it's a percentage, it's not the mean. we're going to set H null equal to 10%. And so we're going to assume that this is true. And then our alternative H1, or sometimes H of sub A, is that the proportion is less than 0.10. And so this is our alternative, and that matches what you see in the calculator. Because when you do this problem on the calculator, you have to be able to tell it what type of test is it going to be. Is it going to be the left tail, the right tail, or whatnot? Now, since P is less than the null, so we're assuming that this is true, which means basically 0.10 is right smack in the middle. We're dealing with a left tail because it's less than. So when you have a less than, that's left tail. If it was greater than, if the alternative is greater than, all of that, okay, you got something here and then something here, that will be a right tail test. And when it's a two-tail test is when the null is not equal to. So I'll write that here. This is just for your notes. So some of you guys, so it could be something like a P or something not equal to some other value. So whenever you have that case where the alternative is set to not equal to something, we will call that a two-tail test. So that right there can get you through a lot of stuff right there, just knowing what type of tail are we going to be analyzing. And it really depends on your test statistic. What is the test statistic? Well, the calculator gave us the test statistic. The calculator said that it is negative 0.7782, and they want 2 decimal places because that's kind of like your standard deviation. So that lets us know how far away it is from the mean. How far away is it from the mean? How probable is it that if under the condition that the entire population has 10%, how likely is it that the alternative, a sample that we collected and tested, is going to be less than 10% and significantly less than 10%? And it's not going to be that far away from the mean. Negative 0.77 is not even one deviation past the mean. So the test statistic is actually going to be negative 0.78 if you round it off. Okay. And now what's the p-value? Well, thank goodness the p-value is given to us. So the way the calculator will, and we can do a test on the calculator as well, but the way the test was set up is that they give you, once you enter the data, they give you the test statistic and the p-value, and they even give us the p-hat, which is the 24 over the 279. They give us that. And then the sample size is 279. But the p equals stands for the p-value, and they want that. Usually it's to 4 decimal places, so it'd be 0.2182. That's the p-value. Now, if we didn't have the calculator, how could you calculate the p-value, right? That's always a good question. What is the p-value? Well, one thing you got to realize is that when we're conducting this test, we're using the standard normal distribution when we start to compare the test statistic and the p-value, which basically means we're setting that the mean is 0 and every deviation is just 1 away, right? Now, the test statistic falls between 0 and -1. It's closer to -1. So it's about right here. Negative 0.78. That's the value. That's kind of hard to see. Let me move that down a little further. That's your test statistic. Okay, so that lets us know how far away it is from the mean. Now, the p-value is the area of the left tail because this is a left tail test. So it's the area from the test statistic to the end of the tail. That's all it is. And the significance level lets us know if we should accept or reject the null based on the p-value. We're going to compare the p-value to our significance level. Now, this p-value is actually pretty high. It's 0.21. That's like 21%. If we compare it to the significance level, the p-value is not going to be less than it. So the entire test falls apart. The test is inconclusive. No result. We can't accept nothing. We can't accept or reject it. We simply have an inconclusive result. And the reason is because the p-value is not less than alpha, which basically means we don't have enough evidence to reject the initial claim that the population proportion is 10%, or the proportion is 10%. The proportion, and based on the context of the problem, whatever the context of that problem is. Okay. So that's kind of what's happening there. As far as some of the other questions there, let's see some of the other questions. That what is the null hypothesis and what do you conclude about it? Well, the null was that p is less than 0.1 and decide whether you should reject or accept it. It's going to be a fail to reject the null. The null is the original one. Right, the null hypothesis is actually has an equal to, and the alternative is the one that's less than. So H null is the assumption. We're assuming that it's true, and then we're going to try to collect enough evidence to reject it. That's kind of how it works. You know, I mean, if you take a DNA test, if a father takes a DNA test to determine if he's the father of a child, you know, the null hypothesis is probably going to be they're going to assume that he is not, and then they're going to check the strands of the DNA and match it up with the DNA strands of the child. And if it's probable, less than some significance level, like less than 0.01%, they can, with certainty, conclude that that guy is the father. But if the p-value after they do the test and it's not less than that significance level, whichever that level is going to be, the test will be inconclusive, where they just cannot determine. They'll have to test again or test someone else. But usually the way it works is it is irrefutable when you get a conclusive result. Now, so here, since we weren't able to reject anything and we ended up getting a conclusive result, the next step, what is the final conclusion? there is not sufficient evidence to warrant rejection of the claim. So let's go back to this one. Decide whether to reject the null. We will fail to reject the null because the p-value is greater than the significance level. And then what's the final conclusion? Again, we have there is not sufficient, let's just read through it. There is not sufficient evidence to warrant a rejection of the claim that less than 10% of treated subjects experience headaches. There is not sufficient evidence to support the claim. So I'm going to go with there is not sufficient evidence to support the claim that less than 10% of treated subjects experience headaches. Now, that claim is the alternative. So when we go back to our example, this is our null, and this is our alternative. And the alternative is usually the claim. The only time in this book that the alternative is not the claim is when you're dealing with a not equal to. And that's how you know that it's not equal to, because then they're trying to just show that the null is true. But in this problem, it said less than. And since we're dealing with something less than, then we know we're going to the left. Well, that's kind of an approach on how you can tackle this kind of problem. Let's move on. Let's look at some more. That was good. I thought that was pretty good. So here's a question, and I could just tell by the looks of it, what is a confidence interval? And it's based on the mean. So there's two different types of confidence intervals. There's the confidence interval for proportion, and then there's the confidence interval for the mean. So you have to know the difference. I believe the confidence interval for the mean is section 7.3. Confidence interval for the proportion is 7.2. Or maybe it's the other way around. Maybe 7.1 is the mean and 7.2 is the proportion. But at any rate, we can do this problem. In order to do this problem, though, I would strongly suggest using technology. They give us the data, and they give us the confidence level. They say construct a 99% confidence interval. So here's how you would go about doing this in your calculator. First thing you have to do is just pull up that calculator. So what I'm going to do, I'm going to find my calculator and pull it up real quick. There it is. And you actually have to enter the data into a list. So there's my data. Now, you could actually open this up in StatCrunch, Excel, and they could also do it. I mean, I saw someone do it in StatCrunch. That's fair game. You could do that. But the correct way to go about doing this, the way I'm going to do it, is using the TI-84. So I'm going to enter all the data into a list. So you got to hit Stat and then Edit. And it looks like all my lists are clear, so I'm just going to just throw them in there. So 0.52, always be careful when this is data entry. If you're going to make a mistake on the problem, it's probably going to come at this point. So you really want to be careful, and after you put in all the numbers, just check and make sure that they're entered in correctly and you didn't make a mistake in this part, because it's pretty sad to be able to make a mistake in data entry. So that's kind of what we're testing you on, is can you enter the data in without making any mistakes? You know, that's kind of how I feel. And then I hit enter. So I have it, and I'm just kind of double checking, cross-referencing. Yeah, it looks like I have 7 entries altogether. So it looks good. And then they said construct a 99% confidence interval. So now the question really becomes, where do we go to do confidence intervals really, okay? So I'm going to go back to the home screen by doing second quit. And I can actually make sure my list is there, right? If you look at that number 1 button, second one is a list. And if I just hit enter, there's my list. So it's already saved. But now the question becomes, where do you go to do confidence intervals? So I'm gonna show you where to go for that. All right, and make note of this if you don't already remember where you go for that. I can show you where you go for that. So we're actually going to go, and it's a test. So we're going to go into stat and then over to tests. And it's simply going to be a t interval. Well, there's two kinds. We have a z interval and a t interval. We also have, let's see, a 1 prop z interval and a 2 prop z interval. So it's not going to be a prop because they asked for the mean. If it was a proportion and they asked for the proportion, then yes, we'd have to go to 1 prop z int. So it would be a. But because they just want a regular interval, I believe it's just z interval. All right, let's check z interval. Okay, there's z interval, and let's just go back in. Let's take a look at t interval. Let's just make sure we're clear on the difference between those two. Okay. They're definitely not the same. It really just depends on what the problem gave us. So the problem gave us a sample, right? Let me go back into our test. Well, let's not lost there. Because we're dealing with the sample, t interval is going to be the guy to use. Because if we go back into, and let's just make sure we're clear on that. If we go back into stats, this is when we have the actual population. We don't have the population. We don't have the population deviation or anything like that. So we can't use z interval. All we have is a sample, and that's for the t interval. And the t interval is when you're going to estimate the population distribution. You're not going to use the standard normal one. You're going to use the estimation one. So that's the difference between t and z. And so let's go back in there, go back into tests, and we're going to go to number 8. And we're going to go into the input. We're not going to put in the stats. We could calculate the mean and the standard deviation and our sample size. We could calculate that. But the truth is we don't have to calculate that for our little sample because we've already entered it into the data. So all we have to do is just say, hey, the list is going to be 1. The frequency, I'll just choose 1 for that. That makes it go away. There is no frequency. It's just the list. And then our confidence level is 0.99. And then we hit enter, and there is our confidence interval, 0.1789, 1.21. And that basically just lets us know that we're 99% confident that the mean of the population is contained within this interval. Like this particular interval is going to capture the real population mean 99% of the time. That's kind of how you would kind of interpret it. Which basically it's a big net. Like it's wider. Like the bigger confidence level, the wider the interval will be. I mean, we're going from 0.17 all the way up to 1.2, and apparently it's a small deviation. So the majority of the data are really close together. So the mean, it should fall within there, within this range. And this is helpful. This lets us know a lot about the overall data when we need to make inferences. All right, and this also can support your conclusions when you have an interval and you do a hypothesis test and you follow it up with, if you follow it up with a confidence interval, then that will let you know, like you can make. We'll do a problem where that happens, but it supports your conclusion when we have to figure out the mean of something. So, all right, let's kind of we're kind of dragging our feet a little bit, so we're gonna just kind of skip through a bunch of these. Maybe once I submit the test, we can then review it and pull up the answers, which would actually be pretty nice. And this problem looks just like the one we just did. Okay, so you just have to read it carefully to be able to answer the very last question. Based on the, then this is what it's all about. Based on the context of the problem, can you now put the results into words? Do you understand what having a confidence interval means based on the problem? And it really has to do with the guideline that they're asking you there. So pretty straightforward, and it's a nice tiny little data set, so we can easily enter it into our calculator without too much time. Oh, so I have to attempt the question? Okay. This is kind of a cool question, I thought. Basically, they give you a confidence interval, and then they want you to put it in this particular form. There's a different form. There's lots of different forms of a confidence interval. But basically, the p hat is the average of the ends of the confidence interval. It's exactly in the middle, which is, I believe, 0.777, okay? And then plus or minus the margin of error. So if we have 0.777, which happens to be in the middle, our margin of error is 0.222. And then that's it. That is it. So when you have to calculate the confidence interval by hand, you have to first find P of hat, and then you have to find the margin of error using the formula, and then you simply add the margin of error to get the upper limit of your confidence interval, and you subtract the margin of error from P hat to get the lower limit of your confidence interval. And that makes up your entire confidence interval. So your confidence interval is that proportion. This is like the proportion that's given, plus or minus your margin of error. Let's just keep going. Find the critical value of z sub alpha over 2 that corresponds to the given confidence level. And I do remember doing something like this on the midterm. And you probably will notice the same thing that I just noticed. And by the way, let's just go back for a second. All right, I don't think I can go back, but I was going to say, how did the question, there was a question that came in, how did I get 0.777 from 555? And the answer to that is I took the average of 0.555 and 0.999. And if you just add them up, to get the middle number, you just add them up, 0.55 plus point. If you add them up and divide by 2, you'll get the middle. So let's see if we can take a look at this question real quick, and let's see if we can do this one. So they want 84%, and they want us to find z of alpha over 2. Now, 84%, we're talking the innermost 84%. Which means the 2 tails, the remaining portion is 16 because the whole thing is 100. So this is 8% and this is 8%. So alpha over 2 is 8%. Because alpha is 16%. Now, we want the positive one. This is the standard normal distribution, 0. So this is a positive z, and this is going to be a negative 1. You take the positive one. So the question really is just, it becomes an inverse norm question. What is this that corresponds to the top 8%? And the way to handle that is the inverse norm. Now, the area to the left would therefore be 92%. It's that 84 plus 8. Well, wait. Yeah, 84% plus that other little portion on the left is that 8%. That's the area to the left. So this is going to be inverse norm of 0.92. Now you can put in the mean as 0 and 0 and the deviation is 1. Or you can leave it out because by default it automatically does that for you. That's going to give you the z sub alpha over 2 answer. Now where would you go for that? Let's take a look back on our calculator again. And if we clear this out, it's that actually it's more of a distribution type of problem. So second distribute, and it's inverse norm number 3. And we have 0.92. We are talking area to the left by default. So we got 1.40. That's actually how many deviations it is above 92%. 1.40 is good there. And I should round that off to 2 places. So it should be 1.41. Let's check that. We're good. So yeah, I mean, it's just a bunch of problems like that. What important features of the poll was omitted? Well, that's interesting. It's kind of one of those easy problems, but then you get it wrong because it's just too easy, and we just don't pay close attention to it. That's what this one reminds me of. So a newspaper provided a snapshot illustrating poll results from 1,910 professionals who interview job applicants. The illustration showed that 26% of them said the biggest interview turnoff is that the applicant did not make an effort to learn about the job or the company. Okay. Um, the margin of error was given as plus or minus 3 percentage points. What important feature of the poll was omitted? And we have the point estimate, the confidence interval, the sample size, or the confidence level. Yeah, you know, there is no confidence level. We do have a margin of error. The point estimate looks like 26%. The poll, everything else it seems like we have, or we could create, like the confidence interval. And it's almost like you could kind of guess this without even having any information, because if you can't get the confidence interval, then you can't have nothing. None of them are right. So, I mean, it's one of those situations. So I'd probably go with this, but actually this question's a little fuzzy to me, to be honest. I don't know. It's just something about it just doesn't seem that clear. Yeah. Oh, so there's the professional. So these are the bosses. 1,910 bosses, professionals who interview. The illustration showed that 26%. 26% of them said the biggest interview turnoff is that the applicant didn't make an effort to learn about the job. Yeah. Yep. I'm going to go with that confidence level. So yeah, the quiz wasn't too bad, guys. What you can do is submit the quiz, and then you go back in, review it. When it says review, you hit review, and then go down to question help. And it shall let you print it off, which it doesn't let you print it off, which is pretty sad. I don't know if this is doing that for me. Maybe I have to sync the grades or something, but yeah. So what we're going to do now is focus in on, let's jump right into the practice final exam. And let's talk about that for a second. It's actually just going to be 15 questions, guys. You got 15 questions and you're home free. It is based on the second half of our course. And that's that's what it's going to be this time around. There's an abundance of time. I don't want time to be an issue. There's plenty of time for you to complete it. Here's a breakdown. Not all of chapter 6, not all of chapter 10. So here's a breakdown. I actually looked through every problem, and here's a breakdown of the section, the number of problems per section that's going to pop up on there, because there are some sections that are not covered. And I'm giving you this. Normally they don't give you this, because it could be too advantageous for you. But I figure since you've come and knowledge is power, why not give that information so that you can zero in on your weaknesses within the sections that I'm going to list right now. So from 6.1, there will be 2 questions. And that's why I put 2Q. 6.2. You know I like 6.2. I tell everybody that I like 6.2. For 6.2, there will be 4 questions. There's no 6.3, but there is a 6.4. Just one question from 6.4. And remember, that's dealing with the central limit theorem. That's like 6.1 and 6.2, but you got to divide the standard deviation by the square root of the sample size. That represents the sampling distribution because you're talking about a sample. So you need a sampling distribution. It's really nice. In chapter 7, 7.1, there will be 2 questions. 7.2, there will be, actually I take that back. Yeah, no, it's true. 1 question. Now, I would suggest watching the Panopto lecture video series in the discussion section. That's where you would go for 7.1 and 7.2. I think I did a good job because I went over how to solve those problems, and I even gave a program. You can program your calculator for certain problems. I don't know if that problem is going to be on the test or not, but 7.1 and 7.2, we do have good support for 7.1 and 7.2. That is the confidence interval section. 8.1, there will be 1 question. 8.2, there will be 1 question. 9.1, there will be 1 question. Nothing from 9.2, and then finally 10.1, there will be 2 questions, and that makes 15. We've reached up to 15. Let's double check that. 2 and 4 is 6, plus 1 is 7, and 3 is 10. 11, 12, 13, plus 2 more is 15. I think this looks a little sloppy, but I think you can comprehend this. So use it, take advantage of this. Maybe this can help you. And if you're watching this, may the force be with you. I really appreciate you guys being here and watching this. Let's get into some problems. I want to take a look at problem 9 from the practice. And I actually downloaded the practice exam here. We have the practice exam. We have all the questions from the practice with their solutions, but they're not worked out. So once you take the practice exam, after you submit it, you can go back in and print it off and have this document. I just printed it into my OneNote, but you can put it wherever you want. Question number 9. Yeah. So here's question number 9. Now, I actually do remember doing this problem maybe a long time ago. I wonder if this is the problem. A study was conducted to determine the proportion of people who dream in black and white instead of color. Yeah, I dream in black and white. This is an interesting study, right? We want to know not only do you do it, but is age a factor or not? Does it depend on your age whether or not you dream black and white? And this is an interesting study. Now, in order to get a conclusive result, you have to carry out a hypothesis test. So that brings us here. Now, among the 320 people over the age of 55, 71 dream in black and white. And among the 290 people under the age of 25, 15 dream in black and white. Use a 0.0 0.01 significance level to test the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. And they tell you, consider the first sample to be the sample of people over the age of 55. So P1 represents the proportion of people greater than 55. And therefore P2 represents the people who are less than 25. Now we do need to calculate the proportion of each one. So P1 hat, again, it's going to be 71 over 320. And then P2 hat is going to be 15 over 290. Now, there's a couple questions. I should check the chat a little bit more. There is a relationship between confidence level and significance level. It's always just 1 minus the confidence. This is a previous problem. 1 minus the confidence level is the significance level. Or alpha. So like in the confidence level, if they say, hey, 99% confidence interval, then your alpha is 1%, because together they make up 100%. They have to give you one. Now, if you have an example of a problem, if you can point me to that example, I can address that question. I don't know what time, when you wrote that, so I'm just looking back. Maybe I don't know if you're talking about this question or not. I don't think you're talking about this particular question, but if you do have a question, so that was one question. And then we have Patty is out there, and we have some questions there. So let's talk about the question. The question I have was regarding the confidence interval. My question for B asked for 90% confidence interval, but in the view, the example question, it states one-tailed tests require 98%. So you're probably wondering why are we using 98% for our confidence interval when we have a significance level of 1%? This is a great question. Now I have the answer to this. When we do a confidence interval, that percentage is based on the innermost level, the center. And because one of the tails is 1%, our significance level is at 1%, the others must be at 1%, which gives us our innermost 98%. And that's what we're going to use. So we were able to figure out that the confidence interval will be 98%. It was probably stated somewhere in the text. But that was not fair for them to do that. You're right. They should have simply stated, use 98% confidence interval. Sometimes they don't tell you and they just say, hey, the interval is this. You need a confidence interval. But now we can figure it out. Now that it's been said that I told you that because the significance level is set at 1%, our confidence level now is the innermost area. You take away the two tails. Because this is the critical region right here. We call this the critical value. It separates the good from it separates the conclusive from inconclusive. So this is the negative one and that's the positive one. Everything else probably fell right out. I did do this problem once upon a time, and it was kind of a nice problem to do. This calculator can do it as well. I can demonstrate where to go to make your life a little easier. You want to see that? And I believe, if I'm not mistaken, we can even do the problem on the calculator as well. Where does it say that at? Are you talking about this question, or was it your question? It asked for 90%. So let's actually do this problem on the calculator, just to kind of show you the process and how easy it really is, how easy it can be. Okay, so if it's 90%, then that's what you'll do. You'll just do a 90%. It's not going to be a problem. But let's look at how we're going to tackle this problem in the calculator. Well, we're dealing with a two-sample proportion, not the mean, a proportion, and it's two samples. So it's a test. We're going to go into stat, go over to tests, and it's number 6. Two proportion test. Z-test meaning hypothesis test, where the Z is the standardized normal distribution. X1 and N1 is the first population of the group over 55. $71 and $320. The second group is the younger group, all right? 15 and $290. Now all I have to do is decide what my alternative is going to be. Now they told you where did they say it at? Use a 1% significance level to test the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. So P1 is greater, which means P2 is less. So I'm going to go over and choose enter there. And that's about it. Let's go down to calc, and it gives me all of this good information. It gives me the test statistic, the p-value. The p-value is very small, by the way. It's 8.19 times 10 to the negative 10. You could just say 0. This is in scientific notation. It is so small. Remember, 6 deviations away from the mean. 6. p hat of 1 is 0.22, so on and so forth. Now, what about if we needed the confidence interval? And we can check and see if they got that as well. They got 6.03, extremely far out to the left, to the right. Now, to get that confidence interval, you just go back into stat, go to test, and then we're going to do a 2-prop z interval test. So that's all the way at the bottom. B, alpha B. 2-prop z, and the data is already stored. You just change the confidence level. They want it 98%, so I'm just going to put 98. Hit enter, and there's my confidence interval. Yeah, you could put the p-value to be 0. It's just so small. So it's all about the distribute function when it comes to confidence. And oh, no, actually, it's all about going into tests. Tests is where the interval, the confidence interval, and the hypothesis tests are. You have the 2-prop z-test, and if you scroll further down, you got the 2-prop z interval. All right. Yeah, these problems are designed to be used for the calculator, to be honest with you. You should be aware of that. So they got, let's check, they got where'd my answer go? I think that already, .108 and .232, and that looks, it matches up here, .108 and .232. Okay. So I think the key is all about just setting it up. They tell you which one they want to be the first one and which one to be the second one. Now, I know this one's going to be not equal to, because it says test the claim that the instantia has an effect rhinovirus infection. So you're basically testing the claim that it has an effect, some kind of effect. It didn't say higher, it didn't say lower. So basically, if it doesn't say greater or it doesn't say less than, you simply choose the not equal to. Now, H null is always going to be equal. It's all about the alternative. And since the alternative is not equal to, that lets us know we're dealing with a two-tailed test. And that's more important if you were doing it out by hand. For us, we don't do things out by hand. You would just enter in, hey, P1 is this 34, 39, 88, 103, and then you put not equal to, P1 is not equal to P2, and your calculator will give you all of these values. Did you guys want me to go through this one, or are we good on this? You want to see something else? I can go through this one on the calculator if you like. Yeah, the E, finding the E is important. You simply have to have the formula. I think I have the formula as well. So yeah. You got to have the margin of error formula. So the formula, um, let me write out the formula for you. That's z sub alpha times the square root of p hat q hat divided by n. Let's take a look at one of the problems that asked for that. So first they want the point estimate. So the point estimate is p hat. A drug is used to help prevent blood clots in certain patients. In clinical trials, among 4,607 patients treated with the drug, 105 developed the adverse reaction of nausea. So that's going to be 105 over 4,607. And you should get 0.023. 0.023 when you round it off. So A is done. And there is a question coming in as, is there a way we can find it using a test on our calculator, or do we have to find those numbers and then plug them in? Yeah, there is no program for this. There is a program that I gave you in the 7.2 lecture video that talks about the number of sampling size, the N. But for this, you would need to solve this. Now, we have p hat. That's part of the formula. It says identify the value of the margin of error. So I need, first of all, in order to do this problem, I need q hat now, which is 1 minus p hat. So since p is 0.023, q hat is actually just going to be 0.977. N is the sample size, 4,607. And now all I have to do now is find the critical value, z sub alpha. It's actually alpha over 2, I should point out. It's just one tail. Construct a 90% confidence interval. So since my confidence level is 90%, alpha is 10%. Let me erase that. and then half of 10% is 5%. So I need to find z sub 0.05. I need to find that value. This whole portion is 95% now. So I can do inverse norm of 0.95. $1.64. So this is 1.64. Now I have all of the pieces for my formula. I have the z alpha over 2. I have p hat q hat divided by n, and then I'm going to take the square root of that, and it should give us 0.004. You probably could. I've never used t-interval to solve this kind of question. I'm actually well, yeah, you could, okay, you could work backwards for sure. Yeah, like if you have the confidence interval, then the difference between the middle, like half of it is the margin of error. 0.004, like the difference between the middle and the end is going to be 0.004 because it's plus or minus 0.04. Okay, yeah, for the confidence interval, yeah, we're not gonna do that by hand. We can use our calculator for that, but we don't have to anymore because look, the confidence interval is this number plus or minus this number. We're putting them both together. You can check 0.023 plus 0.004, 0.026, 0.023 minus 0.004, 0.019. So p hat plus or minus e is the confidence interval. So in essence, we're actually doing a confidence interval problem by hand. That's basically what we're doing. So we actually could have used the calculator for this. We could have just took the information, did the confidence interval, and then worked backwards. And the confidence interval, they give us p hat. So we'll know what's exactly in the middle. And then the difference from the middle to the end and the difference from the middle to the lower bound is e. But let's just see if our calculations is correct. We're basically going to plug everything in and see if it works out, if we get 0.004. So I'm going to take that and multiply it by the square root of 0.023, and then I'm going to multiply that by 0.977, and we're going to divide all of that by 4607. And we got 0.004, which is what we were supposed to get. Now you could have done this problem out by hand. It's going to be, how would we do this problem? You would do, this is what you would do. You would go in the stat, test, and it would be a one prop z interval. One prop z interval, A. Our x is 105, 4607. Our confidence interval level was 0.9. 0, or just 0.9. Hit calculate. We got our p hat is 0.023, and we actually have the confidence interval. We could round it to 3 places and it would be consistent with what the answer has. Now, how would we get the margin of error from this? Well, just take one of the endpoints and subtract it from p hat, since p hat is right in the middle of your interval. The average of the two bounds is your p hat. Okay? See, we're coming full circle today. I actually have a recording of last semester's final review. It's the same exact test. I may have done more problems in that one. I will post that one as well for you. I think it will be helpful. I'm going to post this one as well. Let's take one or two more questions and then we're going to pack it up. But we could probably do this again, maybe. I wouldn't mind doing this again maybe next week, Tuesday. Oh wait, Tuesday is when it opens? Maybe next week. I thought is it Tuesday or Wednesday? Or maybe even Monday, actually. We could probably have like a little, like one last study session on Monday, and it could be a recording. And I want to do problems that I've never done, that I have not done before. So there'll be problems that you may have. Okay, it's on Wednesday yet, but it's actually 2 days, right? So keep in mind that it opens. So if you click on it right now, it says that it's due Thursday midnight, but it opens that Wednesday. So Tuesday we could have a session. That's when the practice final closes. So you'll have more time to do the practice, and we could do that, guys. Okay, possibly. If there's a need for that, just because I just feel like I think it's just useful. It's useful, and you can learn something a minute before you take the test. All right, and then use that knowledge and do well on the test. So that's sometimes people pass by the skin in their teeth. It's like that. I mean, everyone has their own little story of that. So we have to study until the end, so we can be a little bit more confident going in. Yes. The answer is yes, for notes. Yes, you can. That's fine. So if there's no other questions, guys, we're probably going to wrap it up here. Spend some time with the practice. Get familiar with it. Yeah, that's fine. Get familiar with the practice, and then you'll be ready for it. Okay. Okay. Yep. I appreciate you guys being a part of this and being around the whole time. That's just great. All right. Sorry about the quiz. I can't open that quiz back up. I know a lot of people are a little bummed about it, but the homework, you can still edit your homework, go back in and improve your grade. So I take advantage of that. A good grade to have on your homework is anything above 90%. If you have above 95%, then you're doing really well on the homework category. You can't change your quiz grades anymore. You can't change your midterm grade anymore. And I was just looking forward to that final exam. So we're going to end this video here, guys, and reach out to me if you have any other questions or comments or other problems that you would like for me to create videos on. I could do that, or we could come together again next week, Tuesday, and have a good little hour session. All right, you guys are welcome. Enjoy the rest of your day and have a great weekend. Looks like we're getting some good weather. Hopefully it lasts as long, right? New season's on the horizon. Yep. Bye, guys.